Use the data in the following table, which lists survey results from high school drivers at least 16 years of age. Assume that subjects are randomly selected from those included in the table. Here's our table. It says drove when drinking alcohol is the columns, yes or no, and then the rows say texted while driving and no texted while driving. The question says that if 4 different high school drivers are randomly selected, find the probability that they all drove when drinking alcohol. So let's first take a look at the table here. One good thing that you may want to do is just to find the total of all the values of each particular row and column. So if we wanted to find the total, we could do that. So what is the total of the yes columns? If we take 710, add 186, that gives us 896. Okay, what's the total for the no column? We have 3109 plus 4520, and that gives us 7629. Okay, let's find the total of the rows. So if we want to find out what is the total between 710 and 3109, so 710 plus 3109, that gives us 3819. And then for the second row, we would take 186, add 4520, and that gives us 4000. Let's go ahead and move that down here a little bit. And that gives us 4,706. Now, if we wanted to find the entire total of this entire set, we could either add across or add those totals to get the total amount of numbers. Let's just check to make sure that it works. If we take 896, we add 7629, that gives us a total of 8525. If we add those numbers down, 3819 plus 4706, again it gives us a total of 8525. So therefore that is the total. Now let's go back to our question. Okay, it says if 4 different high school drivers are randomly selected, find the probability that they all drove when drinking alcohol. Well, it says drove when drinking alcohol. The answer is yes. And what is the total out of that entire column? Well, we have 896. So, again, find the probability that one randomly selected high school driver drove when drinking alcohol. So we want to first find that. In order to do that, we decide that the value of n, or the column that we're looking for, is 710 plus 186, which gives us 896 students who drove when drinking alcohol. And the total number of high school drivers in this survey is adding up all these numbers, which we get the total of 8,525, which we've already done. Okay, now we want to determine the fraction to find the probability that one randomly selected high school driver drove when drinking alcohol. And therefore, n is equal to 896 and x is equal to 8,525, and then the fraction can be shown as follows. So if we want to find the probability of one randomly selected student, in this case it would be the fraction 896 divided by 8525. So that would be one randomly selected student. Now, when considering the value of the probability of event B occurring, provided that A has already occurred, we take into account whether or not A and B are dependent events. Now, 2 events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. So if A and B are not independent, then they are said to be dependent. Now, the selection of the first high school driver does not affect the probability of the outcome of the next high school driver because they are dependent events. So the same high school driver cannot be selected more than once. Thus, the probability of each driver being randomly selected will not be exactly the same because the events are dependent. However, the total number of high school drivers, 8,525, is much larger than the numbers of drivers being selected, which is 4, because the sample size is less than 5% of the total population. So the calculations can be simplified by assuming the events are independent. So if we took 5%, 0.05 of the total of 8,525, we would see that number is a lot larger than the 4 that's being selected. And that's why we can assume that the events are independent. So now that we can assume that they are independent, now what we want to do is multiply the probabilities of 4 independent choices to find the probability that 4 randomly selected high school drivers all drove when drinking alcohol, and then rounding it to 6 decimal places. So what we're doing is we're taking the probability of the first student being randomly selected times the probability of the second student being randomly selected all the way to the fourth student. Well, if we go back, we know that 896 over 8,525 represented the first students. So we're taking 896 over 8,525, and that is the first student. Then we're going to multiply it by the next randomly selected student, which is 896 over 8,525. And then the third student is 896 over 8,525. And then times 896 over 8,525. Okay, now another way that we can write this is the following. We can say that this is 896 divided by 8,525, and that's to the 4th power since we're multiplying it 4 times. So let's go ahead and do that in our calculator. So we're going to say parentheses 896, and then we're dividing that by 8,525, and then we're going to raise it to the power of 4 to get this result. So we end up getting 1.22026, and we'll leave it at that, multiplied times 10 to the negative 4, because that's what e to the negative 4 stands for. So now if we want to round this, okay, what we want to do, and I'm going to just kind of slide this over a little bit here. Okay, we first want to then apply the negative 4, so we got to move this over to the left 4 times. So that means we're going to get 0.0001, 1, 2, 3, 4, and then we have 2, 2, 0, 2, 6. Okay, now the next thing we want to do is round this decimal to 6 decimal places. So if we go over 1, 2, 3, 4, 5, 6, this 0 tells us that we don't need to round up, and so therefore we can approximate this probability to be 0.000122. Let's go ahead and check our result there. So that represents the probability that 4 randomly selected high school drivers all drove when drinking alcohol. So we have 0.000 and then 122. Check our result, and there is our answer.